let's discuss new concept, conductance. Before going for conductance, we should know what is resistance. Resistance is the obstruction to the flow of current and it is indicated by R. Resistance of material is directly proportional to the length L. If you see the picture in this one, this resistance it is directly proportional to the length. This is the length of the material or the length of the conductor, and it is inversely proportional to the area of cross section and it is indicated by A. This is the area of cross section. Therefore, we can write R is directly proportional to L and it is inversely proportional to the area of cross section A. Or we can write R is equals to rho into L by A. This proportionality is replaced by one constant that we call it as rho. So R is equals to rho into L by A. Resistance R is equals to rho into L by A, where R is resistance in ohms, L is length of the conductor in centimeter or in meter. A is area of cross section in centimeter square or meter square. Rho is called as the resistivity of the conductor or it is also called as specific resistance. Now we will consider conductance and it is denoted by G. It is the reciprocal of the resistance. Therefore, G is equals to 1 by R. That is, G is equals to 1 by rho into A by L. G is equals to K into A by L because 1 by rho is equals to K. SI unit of conductance is Siemens, or it is denoted as S, or it is ohm inverse. K is called as the conductivity of the conductor, or it is also called as specific conductance, and it is called as kappa. G is equals to K into A by L. Therefore, K is equals to G into L by A. K is nothing but it is the conductivity or it is specific conductance, that is equals to G into L by A. The unit of conductivity is Siemens per centimeter or Siemens per meter. Conductivity of electrolytic solution. Let us consider an electrolytic solution and the electrode 1 and 2 which is placed in the electrolytic solution, which is 1 unit apart, and the area of cross section of electrode is 1 square unit. The conductivity is defined as the conductance of an electrolytic solution which is placed between two electrodes which are 1 unit apart, and the electrodes have an area of cross section is 1 square unit. That is the conductivity, or it is also called as specific conductance. Let's discuss about conductor, insulator and semiconductor. Depending upon the magnitude of conductivity, the materials are classified into three types. First one is conductor, second one is insulator, the third one is semiconductor. First one, conductors. Conductors are the substances which allow the passage of electric current through them. They have very high conductivity values. Example for conductors, metals and electrolytes. Second one, insulator. Insulators are the substances which do not conduct electricity and they have very low value of conductivity. Examples are glass, ceramics. These are the example for insulator. Third one, semiconductor. These are the substances which have conductivity values between that of conductor and insulator. Examples are silicon and germanium. Is there any materials which has zero resistivity and infinite conductivity? Yes, they are called as superconductors. Niobium superconducting alloy is used in MRI scanner. Types of conductors and electrolytes. How are conductors are classified? There are two types of conductors. First one is electronic conductor. They are also called as metals. Second one is ionic conductors. They are also called as electrolytes. Let us discuss about the electronic conductor and ionic conductors in detail. What are electronic conductors? The electronic conductors, they are also called as metals. In electronic conductors, electrons are responsible for the conduction. Therefore, metals are called as electronic conductors. Factors influencing electronic conductivity, that is conductivity of metals. First one is number of valence electrons. More the number of valence electron, more will be the conductivity. The second one is temperature. As the temperature increases, conductivity decreases, because as the temperature increases, there will be a resistance for the free flow of electrons. Hence, the conductivity decreases in case of metals as the temperature increases. The third one is nature and structure of conductor. So here the structure of conductor is also very important, because the conductivity depends on the length of the conductor. If the length of the conductor is more, then there will be more resistance for the flow of free electrons. That's why conductivity will be decreasing if the length is increased. What are ionic conductors? The ionic conductors, they are also called as electrolytes. It may be strong electrolyte, it may be weak electrolyte. They conduct electricity by the movement of ions in the aqueous solution. The electrolytes are called ionic conductor or electrolytic conductors. Next one is factors influencing ionic conductivity. First one is the nature of electrolyte added. It depends upon the nature of electrolyte, means whether the electrolyte added is strong electrolyte or weak electrolyte. If it is strong electrolyte, dissociation will be complete, the number of ions will be increased. If it is a weak electrolyte, then the dissociation is not complete, it is a partial one. That's why the number of ions will be less, so that the ionic conductivity will be decreased. The second one is size of the ion produced and their solvation. So depending upon the size of the ion, if the ionic size is less, then the movement of ion will be easy, so that the conductivity also increases. Third one is the nature of solvent and its viscosity. If the solvent is polar, then more ionization takes place, so that the ionic conductivity increases. And it's also depending upon viscosity. If the liquid or if the electrolytic solution is more viscous, that means there will be resistance for the free flow of ions, so that if the liquid is more viscous, then the ionic conductivity decreases. If the liquid is less viscous, then the ionic conductivity will be increases. Fourth one is concentration of electrolyte. More the concentration of electrolyte, more will be the number of ions, more will be the conductivity. Fifth one, temperature. It increases with the increase of temperature. That means conductivity increases with increase of temperature, because as the temperature increases, the dissociation of ions or dissociation of electrolyte increases. More number of ions are produced in the electrolytic solution. Hence, the conductivity also increases with increase in the temperature. Types of electrolytes. There are two types. First one is strong electrolyte. The second one is weak electrolyte. Strong electrolytes dissociates completely when dissolved in water, whereas weak electrolyte dissociates partially when dissolved in water. Example for strong electrolytes: it may be strong electrolyte, it may be salt, or it may be strong acid, or it may be strong base. Examples: NaCl, KCl, these are salts. HCl is a strong acid, NaOH is a strong base. Weak electrolyte, it may be weak acid or it may be weak base. Acetic acid, it is a weak acid, it is a weak electrolyte. NH4OH, it is a weak base, it is a weak electrolyte. In strong electrolytes, ion dissociates completely, whereas in weak electrolyte, ions dissociates partially. That's it from this particular module.